Hello friends, this video is created by Siddharth Upadhyay, founder and creator of PrepWings. Log on to www.prepwings.com for complete free course videos. In this video, we'll cover the topic polygons. Polygon is a closed figure having three or more sides. So names of various types of polygons are shown here. A three-sided polygon is called a triangle. Four-sided polygon is called a quadrilateral. Five-sided polygon is called a pentagon. Six-sided polygon is called a hexagon. Seven-sided polygon is a heptagon. Eight-sided polygon is an octagon. Nine-sided polygon is a nonagon. And a 10-sided polygon is called as a decagon. Okay. Now over here we see a five-sided polygon. Okay. And we'll discuss the different elements related to the polygon. So a side of a polygon is a line segment of the polygon. For example, over here, the five-sided polygon AB, BC, CD, DE and AE are the five sides of this polygon. Okay. Vertex is the point of intersection of sides. So in this polygon, A, B, C, D, E are the vertices of the polygon. Okay. Diagonal of a polygon is a line connecting the vertices that are not adjacent. So a diagonal EC is shown over here. Okay. Then interior angle of a polygon is the angle formed by the adjacent sides inside the polygon. So if you look at angle EAB, that is x degree, that is inside the polygon. Okay, so it's an interior angle. Exterior angle of a polygon or the external angle of a polygon is formed outside the polygon by extending one of the sides of the polygon. An example shown over here is y degree because that's at vertex B and that is formed by extending the side AB. And it is outside the polygon. So y degree is the external angle and x degree is an interior angle. Okay. Now, if you look at the sum of interior angle of an n-sided polygon, it is given by n minus 2 into 180 degree. So what it means is, if I want to find the sum of interior angles of a pentagon. So in a pentagon, n is 5 because pentagon is a five-sided polygon. So the sum of interior angle of pentagon will be given by 5 minus 2 into 180, which is 540 degrees. Okay. Similarly, sum of interior angle of hexagon can be formed. So for a hexagon, n is equal to 6. So the sum of interior angle of hexagon is given by 6 minus 2 into 180 degree, which is 720 degree. Okay. Now we look at regular polygons. A regular polygon is a polygon in which all the sides are equal and all the interior angles are also equal. Okay. A regular triangle is nothing but an equilateral triangle. Okay. Similarly, a regular quadrilateral is a square. Now over here, the question asks us to find each interior angle in a regular hexagon. Okay. Now we know the formula for sum of interior angles in a regular hexagon. Okay. That is given by 6 minus 2 into 180 degrees, which is equal to 720 degrees. Okay. So sum of interior angles of all the angles in a regular hexagon is 720 degree. Okay. But all the angles are equal. Okay. And there are 6 angles in a hexagon. So each angle will be measuring 720 degree divided by 6, which is 120 degree. Okay. This is a regular hexagon. So all the angles have to be equal. Okay. So each angle measures 120 degree in a regular hexagon. Okay. Now, the question here asks to find the area of a regular hexagon with side 3 cm. Now, a regular hexagon has an interior angle of 120 degree. What we can do is we can break this regular hexagon into 6 equilateral triangles. Okay, and the hexagon is of side 3 cm. So, the equilateral triangle has each side measuring 3 cm. Okay. So the area of an equilateral triangle is given by the formula under root 3 by 4 into side square. Applying that formula for one equilateral triangle with side equal to 3, we get area of an equilateral triangle to be 9 into root 3 by 4. Okay, and there are 6 such triangles. Okay, so area of the hexagon will be 6 times area of one equilateral triangle, which will be equal to 6 into 9 into root 3 by 4, which is 54 root 3 by 4, which becomes 27 root 3 by 2. Okay. So the area of a regular hexagon when each side is 3 cm is equal to 27 into root 3 by 2. Okay, so this is all about polygons. Thanks a lot for watching this video.